Welcome to the training course. In this short video, we will be looking at the psychological side of decision making. We will learn that our brains have evolved to be efficient, to take shortcuts, and to trust our intuition. Under the right circumstances, this can be very helpful. But for complex decisions under uncertainty, this can lead to poor decisions and poor outcomes. We will show that perception is not always reality. Information that we assume to be factual may not be correct, and our reasoning or manipulation of the information is often wrong. There are many optical illusions that demonstrate that things are not always what they seem to be. The lines in this diagram appear to be bent, but in reality, all are straight and parallel. And in this famous illusion by Edward Adelson, it seems obvious that squares A and B are different colours. When the surrounding areas are covered up in white, we can see that they are, in fact, the same colour. However, as soon as we remove the white from the surrounding areas, they again look different. Even though we now know that they are the same colour, we still perceive them to be different. Research has shown that the human mind operates largely out of view of its owners. This may be because that was the way it evolved initially, and because that is the way it works best under many circumstances. Without such a quick and effective way of understanding and acting on the world, it would be difficult to survive. We would be stuck mulling over every little decision, such as whether to put our left or right foot forward, as the world sped by. However, as a result, we are strangers to ourselves, unable to observe the workings of our own minds. This means that we believe that we know ourselves. We believe falsehoods to be facts. We believe that we are making good judgments, and we know when we've made a good decision, when none of this is necessarily the case. There are two ways we make decisions and judgments, for which Daniel Kahneman coined the phrase thinking fast and slow. System 1, or thinking fast, uses the subconscious mind. It is intuitive and automatic. As an example, if I'm asked what 2 times 2 is, I instantly say 4. I don't need to think about it. It is based on memory and no deliberate thought is required, so is low on effort. System 2 has greater accuracy and requires more computational power, but is slow and interferes with other thoughts and actions. For example, if I'm asked what 23 times 49 is, well, I definitely need to stop and think about that. Both systems can be useful in the right context. System 1 is useful for decisions of little consequence. System 2 is for decisions of importance that require thinking about. However, we don't like the effort of thinking, and we often create reasons to justify relying on System 1. This training module focuses on the use of System 1. The next module will focus on decision making using System 2. The two ways we make decisions, i.e. System 1 and System 2, or thinking fast and slow, can be looked at from a neuroscience perspective. There are 2 neural pathways in mammals. One goes directly from the thalamus, the part of the brain responsible for relaying sensory and motor signals, to the amygdala, the part of the brain that has primary role in the processing of memory and emotional reactions. It is very quick and has minimal processing. It's an early warning system. For example, if you see a coiled snake-like object ahead of you in the path, it causes you to jump back and stop. This happens before you explicitly recognize the object. The other pathway goes from the thalamus to the neocortex, responsible for processing and thinking, then to the amygdala. It is slower, but with more detailed analysis of information. It causes you to realize that the snake-like object is a coiled rope. Hence, these two pathways are both very useful and have their place. For System 1 decision making, we depend primarily on two hardwired sub-processes. Our brains assess what is going on using pattern recognition. We react to that information or ignore it because of emotional tags that are attached to our memories. Both sub-processes help us make adequate decisions in simple situations. They have survived evolutionary selection because they give us advantages over other animals in making decisions about basic survival needs, such as water, food, and shelter. But for modern-day complex situations, both can mislead us, resulting in poor judgments and bad decisions. Pattern recognition is a complex process that integrates information from as many as 30 different parts of the brain. When faced with a new situation, we make assumptions based on prior experiences and judgments. For example, a chess master can assess a chess game and choose a high-quality move in as little as 6 seconds by drawing on patterns he or she has seen before. But pattern recognition can also mislead us. When we are dealing with seemingly familiar situations, our brains can cause us to think we understand them when we do not. For example, if you catch a glimpse of someone walking by, you may instantly recognize them as a friend. But when you look again more closely, you realize that it's someone else. When the brain stores a memory of an event or action, it also stores an associated emotion with it. This is emotional tagging. At the psychological level, there is a long accepted view that emotionally charged events are likely to be remembered better. Emotions, such as fear, anger, pleasure, and love, are elevated states of arousal that enhance memory and recall of the events occurring during those emotional states. The translation of this into neuroscience has led to the proposal of the emotional tag concept, whereby the amygdala is activated by emotionality, resulting in changes to the brain regions involved in forming the memory of the emotional event. Actions we have taken previously, whether driven by rational decision-making or not, are filed in our brains with emotional tags that serve as markers that can anchor subsequent thinking. When we need to make a decision, our brain will recall past situations that seem similar to the current one and access the emotions that are tagged to them. These emotions impact the current decision, even though they may not be relevant to it. Under the right circumstances, pattern recognition and emotional tagging are very helpful. For example, the chess master quickly selecting a move. However, this is not the case for complex decisions under uncertainty, which should be made by a process that uses System 2 thinking, such as described in the next training video. But this does not happen naturally. Instead, we use pattern recognition to analyze a situation and arrive at a decision on whether to act or not, guided by emotional tags and memories that may not be applicable or representative of the current situation. The two processes happen almost instantaneously. Indeed, our brains leap to conclusions and are reluctant to consider alternatives. Research shows us that we have defective memories and, so, may not always be right. Ulrich Nieser carried out a study on the Space Shuttle Challenger disaster. 106 students wrote down their memories of what happened, where they were, and how they felt about the event and details of the event. They did this one day after the event and 2.5 years later. 25% were strikingly different. 50% had lesser errors, and less than 10% had all details correct. Prior to having their original scripts handed back to them, most students presumed that their memory was correct. We are subject to many heuristics and biases that impact our decision-making. Heuristics are simple procedures, rules of thumb, that provide quick answers to questions. For example, it may be difficult to judge how good a wine is by looking at the bottle, so we may use the heuristic of price, i.e., cheap equals poor quality, expensive equals good. Heuristic methods are used to speed up the process of finding a solution via mental shortcuts to ease the cognitive load of deciding. Sometimes heuristics provide a satisfactory answer, but sometimes not. For example, not all expensive wine might be good for the decision maker, and vice versa. Problems occur when heuristics cause biases, which are systematic deviations from a standard of rationality or good judgment. Heuristics and their resulting biases arise from our tendency to rely on System 1 thinking. Overconfidence describes situations where a person's confidence in their own judgments exceeds the observed accuracy of those judgments. For example, in one survey, 84% of Frenchmen estimate that they are above average lovers. In another survey, 93% of US students estimated themselves to be above average drivers. Of course, only roughly half of people can be above average, but respondents think it is other people who have made wrong assessments, not themselves. Availability is a bias that prompts us to overestimate the probability of occurrence of recent or most vivid events, i.e., those which are most easily recalled. An example of the availability bias is shark attacks, which people think are relatively frequent because of media reports. In fact, you're more likely to be killed by a part that's fallen off a plane, which in itself is incredibly unlikely. An inside view is based upon the specific circumstances of the task using information that is close at hand, and it makes predictions based on this. This inside view tends to be optimistic. By contrast, the outside view uses data from similar cases to obtain a comparative forecast, which tends to provide a more realistic prediction. However, a large number of projects are based on the inside view, which is why you see so many headlines about projects that are running late. Biases are a major cause of poor decision outcomes. In summary, our brains have evolved to be quick and efficient. Most of the time, they operate mainly at the subconscious level and outside the view of their owners. We prefer to rely on our intuition, and we use heuristics to make decisions because it is less effort. This can work well and is efficient for decisions of low consequence, where an imperfect choice does not matter. It does not work for important decisions. For these, we need the support of some tools to help us to make good decisions. We'll explain more in the next two videos.